Moshi Moshi! Welcome back! Okay, we're gonna do the last of the graphs, right? Remember, we did sine and cosine. Now you know what to expect. You know what they look like. You know their shapes. You know their characteristics. You also even know how they can be applied, right? Periodic functions, right? And sine and cosine functions, and what kind of things can be told by them. What can we analyze? What are the things that we can tell from something that's periodic, right? Based on the graphs, okay? But now we're gonna do the last one remaining. Tangent graph. What do they look like? Okay, what kind of characters do they have? Does it have? And more. Okay. So now you have to bear with me. My handwriting is even worse than ever because I got my full-on splint that I need to keep on for a week. Okay, so bear with me. Okay, don't show your parents these notes because they're going to be kind of ugly. How about you tell them about it? Okay. That's better, okay? All right, so again, how do you graph tangent and reciprocal functions? Please follow along on your notes and please take really good notes so you can actually utilize your notes. And it's 4.5 in your textbook, and I've given you this handout. Part 1, the tangent graph, its basics, and how to graph. And this is the exact format that sine and cosine is also on. Part 1, the tangent graph, its basics, and how to graph. And here are your STDs, right? Your STD number 1, right? We're going through the same sort of format, okay? F of x equals tangent of x, or I guess we can also write this as f of x is equal to, if we have amplitude and also maybe frequency transformation, right? We also have this guy here, which is also the transformational STD. And this guy is the best because we talked about this many times. This shows you phase shift. And this guy always tells you how far did I go up or down in my graph when I'm starting, okay? And this. And you'll see how in tangent, the VS or the vis or the vertical shift is not as important, okay? You'll see, all right? So what I'm going to do is I'm going to introduce you. Oh, sorry, I started writing on this already. I mean, we could label the scale, okay? So we're going to let's just label and then we'll move on. I'm going to do these notes as similar to our sine and cosine as possible so you understand how it works, okay? So let's just talk about the basics. We have this right here, right? This or this, the ABCs, right? So let's talk about the ABCs, all right? First, what do you think the A stands for? Okay, exactly. It's the amplitude, like always, amplitude. Nothing changes until a little bit later, okay? Number 2, you're right. It always has a peanut butter, right? So we'll do P first, even though B is first. P, it's a period. But period is a little bit different than sine and cosine. Dun, 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 dun. And you'll understand if you actually think about it and if you hear it, okay? The period is not going to be 2 pi over B. Rather, it's going to be pi over B. And you know what I'm going to do? I'm going to highlight this one. And you should too, because you should remember that it's different. You know how I tell you never to really memorize, but here's one of those things that are kind of like stand out. It stands out a little bit. So please remember this, okay? Period for tangent is pi over B. Period of tangent is pi over B, okay? Let's go 3. You remember, we have ABCs to take care of. B, again, it's frequency. Okay, it's frequency, like it always is, okay? And we also have number 4. The midline. Okay, midline or D, right? For the tangent line, I'm going to put a little star here. We don't really have any. Okay? You'll see why very soon, okay? 5, we're going to have, of course, a D or the VS, right? Vertical shift. It's not so important in a tangent graph, okay? Again, if you know all this information for some reason, you can speed up the notes, okay? Number 6, which is your C over B, right? That's the same, okay? Now, all this is exactly the same thing. So I'm going to box this up, and you're like, okay, it's more or less same, but a little different, okay? But now let's move on to number 7. Okay? Let's talk about the domain and the range, okay? And we're going to talk about the I think continuity. Is this graph continuous? And if you remember sine and cosine, there was always continuity, okay? So think about all this, okay? And number 9 is going to be our something different, asymptote or as, okay? Okay? All right, we're going to do all this, but before we do, I'm going to tell you that this stuff is tricky dicky, okay? All right, so as you remember, when you plug in your sine, what is the tangent of 0? Let's actually start plugging it in. So you know how we have this? Okay? What's tangent of 0? You're right, it's 0. What's tangent of, I don't know, pi over 6? It's short over long, so it's going to be 1 over root 3. And you know what I'm going to do? I'm actually going to tell you the decimal equivalent. This is about 0.577. Okay? What's tangent of, next one, pi over 4? It's actually 1 because its opposite and the adjacent are equal. What's tangent of pi over 3? You know, we're just dealing with special right angle values, right? It's going to be not 1 over root 3, but it's going to be long over short. Therefore, it's root 3, which is approximately 1.732. What is about tangent of pi over 2? That means we've completed 1/4, right? So 1 first quadrant, which is going to be 0. Oh, sorry, undefined. Sorry, undefined. Undefined, okay? Okay. Interesting values here. We can start graphing. 0, 0. Tangent of 0, 0. Pi over 6, we'll do pi over 2 first. Well, let's do pi over 4 first, which makes it easy, right? Because we have 0 and pi over 2, so pi over 4 is somewhere between, which is 1. So we're going to put a 1 there. Pi over 2 is undefined. What the factor? Well, I think you learned in Algebra 2, right? In Algebra 2, you learned that if something is undefined, that there's either a vertical or a horizontal as or asymptote. So in this case, we're plugging in the x value. X is undefined at pi over 2. That means it must be a vertical as. So we're going to put a vertical as at pi over 2. Again, because it's undefined. But okay, let's now fill in the pi over 3 and pi over 6. Pi over 6, as you know, is between 45, but a little bit closer to 45. So it's about 0.577, so maybe like right here somewhere, okay? Okay, and then we have pi over 3, which is root 3, 1.733, not quite 2, but maybe somewhere like that. Okay, we're just kind of estimating these values. It doesn't matter how close they are. Of course, it looks like it's just connecting dots and it's going to be a straight line, well, towards the asymptote, okay? But you know what I'm curious about? How about the other side? Because I mean, hopefully this repeats after the asymptote, right? It's the same thing here, which looks weird, okay? But how about from here to here? So let's go backwards. What's tangent of, right? What's tangent of, tangent? So I want you to think, if we just took care of the stuff from this quadrant, right? But if we go negative direction, we know we're going here. So think about the tangent values. It's the same, but a little different, right? They're opposites, right? Because we had a positive and a positive slash. On this quadrant, it's positive and a negative. So we know it's going to be a negative value, so the opposite, okay? So we're going to go here, but you know that it's going to be a negative 1. You know it's going to be an other asymptote because tangent of negative pi over 2 is also undefined. And every other coordinate is completely the reverse, right? So this guy's going to be somewhere right here, maybe. This guy's going to be somewhere right here. I know, it freaking looks like a straight line, but actually, the tangent graph looks like this. Ooh, it's a nice curve going towards the ass. Don't touch the ass. It's a nice curve going towards the ass. And that's one cycle of your tangent graph. Ta-da! Okay, so chicos, this is what a tangent graph looks like. It's very different from sine, don't you think? But we're just following the mathematics and the calculations, okay? Now, I want you to look at this. Now, tell me, okay? If we were to do this again, okay, well, you know what? What's the distance from the asymptote to the asymptote? You're right, it's pi. That's why the period of a tangent is pi over b. I don't know if you guys remember this, but period of sine, cosine was 2 pi. But one period of tangent is actually pi. One complete cycle of a tangent graph or tangent function is pi. It's half of sine and cosine. So this completes your first cycle. The next cycle is going to happen where? The next asymptote, of course, right? The next episode happens after a pi away. So what's half a pi plus another pi right here? So you know what I'm going to do? I'm going to draw another S. Nice. Okay. And the same thing repeats. This tangent graph, you'll find that it's the easiest graph to graph. Here's why. The middle is going to be 0. Well, think about it. What's tangent of pi? Tangent of pi is 0 because it's 0 over negative 1. And then you go positive 1 because it's between. What's tangent of 3 pi over 4, right? Okay, think about it. And then you have tangent of here, right here. It's always the same values repeating, okay? So then you graph. Okay, that's what quadrant is that? That's going from, think about it. This takes care of these quadrants. This guy takes care of these two quadrants. That means tangent of 3 pi over 4 is negative 1. Tangent of 5 pi over 4 is positive 1. That's why it's here. So you know what I'm going to do? I'm going to write that for you here. 3 pi over 4, 5 pi over 4. This was pi over 4, negative pi over 4. Okay? And that's how it continues. Well, then I guess you can now probably make a prediction or a hypothesis on what the next one to the left of the negative is going to look like. Go travel a period 1 pi away and start with your S. Nice S. Woo! Okay? And then you're going to graph the middle, positive 1 and negative 1. And then you're going to draw this nice curve. And what you're going to do for me is you're going to indicate that it continues by drawing some arrows, some legs, right? I feel like those are just legs, okay? Just draw something like that for me, okay? That's good enough. And now you've completed 3 complete cycles of tangent graph. Now, based on your graph, let's continue with our information and basics for tangent graphs. So tell me, what's the domain? Oh, wait. Answer the easy stuff first. Is it continuous? Is a tangent graph continuous? Does it go on without any kind of breaks? No, it's absolutely not. It's not continuous. Obviously, because it's got asymptotes. Now, asymptotes are things or lines that you can approach but cannot touch. Can't touch this, okay? You're going towards it, but you'll never be able to touch it. No! Okay. Okay, you can't touch it. All right. So tell me, I want to know something here. Okay, well, you know what? What do you want to do first? Range, domain, or do you want to do asymptote? Let's do domain and range first because it's number 7, okay? Let's do range first because it's easy. Look, how does the y value have any kind of restrictions? Does it go continuous on forever and ever up and down? Yes. So the range is all real numbers, or we can say negative infinity to infinity, all reals, okay? You can say that for rangy. But it's very tricky for domain, okay? You know what I want to ask you? I want to ask you the first time that you run into from 0 to pi over 2, right? Isn't pi over 2 the first time you encounter that it cannot be pi over 2, right? And then another pi later, it happens again. Pi reverse, right? Every pi over 2, I'm going to go this way, no, from here, from the first asymptote, pi over 2, I have to travel pi to get to the next asymptote. What happens every time you drive your period? Every time you travel your period, you hit into a wall that you cannot touch. How far? Every period. In this case, it's the STD, so it's every pi that it happens. So here's how we indicate the domain, okay? Domain is this. X cannot equal. Listen, when did you first start? When did you first start your asymptote, right? When did the S first start? That's what you got to think about. It started at pi over 2. But wait a minute. It repeats every single time, right? Every single pi that it repeats, right? Look, it started here, but every single pi it repeats. So we're going to go plus pi k. It happens every k. But watch this. K is all integers. This means integers. Integers are positive or negative whole numbers, right? So that means domain is, it cannot be pi. Oh, pi, right? What happens when you multiply pi times 1, the first integer? It's adding pi. That's 3 pi over 2. Well, the integers are positive or negative, so I'm going to put a negative 1. What's pi over 2 plus pi times -1? It's this guy here, and so forth. Okay, so that's how integers work. That's how it works. So that's the domain. And this is the trickiest part. So you know what I'm going to do? I'm going to highlight that sucker. It's tricky dicky. But you know, if you know how to write the domain, you know the asymptote. When do the asymptotes happen? When do the asymptotes happen? Well, same thing. It happens, it's a vertical line. It happens every x when it's pi over 2. But every other time after pi. Every pi, every period it happens. But you have to indicate that k is an integer. Positive or negative whole number, including 0. Okay? So that's how it works here. If this is confusing for you, it's kind of new, that's why. Make sure you clarify this for me. But let's recap. Domain or the asymptote, you always start at the first as that happens. Of course, when we have transformations, this could change. This right here, it's because it happens every period that you travel. But not all tangent graphs have the same period. So whatever your period is, it's going to repeat every k times. Okay? So that summarizes your tangent basics. Good luck. We're going to start graphing in the next video, so don't forget to watch.